Appendix B.1 The Cartesian Plane. Some terminology that you need to be familiar with. Most of these terms you should already know, but just reviewing them. X-axis, y-axis, and origin. The x-axis and y-axis are the two axes that make up the coordinate plane. The x-axis is the horizontal axis, going from left to right, and the y-axis is the vertical axis, going up and down. Point where those two number lines intersect is the origin of the coordinate plane. When we name quadrants within the coordinate plane, we name quadrants with Roman numerals. Starting in the upper right is quadrant 1, and as we rotate counterclockwise, quadrants 2, 3, and 4. Ordered pairs. Ordered pairs give you directions on how to get to a certain point in the coordinate plane. If we're talking about the ordered pair that describes the origin, that ordered pair would be 0, 0. When we talk about ordered pairs, they always need to be enclosed within a set of parentheses, and the two numbers must be separated by a comma. First number is the x-coordinate. That's how far left or right you move. Second number is the y-coordinate, how far up or down you move. Distance formula. Used to find the distance between any 2 points. Distance formula is the square root of the difference in x's squared plus the difference in y's squared. Students make mistakes with the distance formula. Normally it's because they fail to follow order of operations underneath the radical. Remember, order of operations here, we must do the subtractions first, then we must square each thing, then add the two together, and finally the last step is to take the square root of the entire sum. Midpoint formula. Midpoint formula is simply finding an average. Add them up, divide by how many they are. If we're finding the midpoint between 2 points, that means we add the x-coordinates together, divide by 2, add the y-coordinates together, and divide by 2. That will give us the midpoint. Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. That's how most students know it. However, make sure you understand what a, b, and c represent. A and b are the two legs of the triangle, or the two sides that contain the right angle. The hypotenuse is the side directly across from the right angle, always the longest. Remember, Pythagorean theorem only holds true if we are talking about right triangles. If it's not a right triangle, you cannot apply the Pythagorean theorem. Finally, standard form of a circle, x minus h squared plus y minus k squared equals r squared. Two things we must know to be able to graph a circle, two things we must know to be able to write the equation of a circle are the center of the circle and the length of the radius. In standard form, we identify the center of the circle by the opposite of what's being added or subtracted from x, in this case h, the opposite of what's being added or subtracted from y, in this case k, and the radius is always the square root of whatever constant is isolated on the other side. In this case, the square root of r squared is just r. Applying the distance formula and midpoint formula. Find the distance between them and the midpoint of the following 2 points. Let's first use the distance formula. Distance formula, again for review, difference in the x's squared plus the differences in the y's squared. Now, when you plug into the distance formula, it does not matter which order you subtract the things because we're squaring it. It's always going to take care of the signs. Difference in the x-coordinates, in this case, -2 minus 3 quantity squared. Difference in the y-coordinates, 1 minus 4 quantity squared. -2 minus 3 is -5. 1 minus 4 is -3. Square each of those. -5 squared is 25. -3 squared, it's 9. Distance is root 34. Throughout the entire year in this class, make sure that you are always giving your answers in simplest form. Do not give decimals unless if you are told specifically to do so in the directions or you have decimals in the original problem. In this case, root 34 cannot be broke down, so that is the simplest form in which we can give the solution. Midpoint formula. Remember, midpoint is simply finding an average. So I want to add the x's up, divide by 2. I want to add the y's up and divide by 2. Add the x's up, -2 plus 3 divided by 2. Add the y's up, 1 plus 4 divided by 2. And we get the ordered pair 1/2, 5/2. Again, I'm going to leave those in fractional form. They already are in simplest terms. Number 2, point 34 lies on a circle centered at -1, 2. Write the standard equation of this circle. Well, we're asked for the standard equation, and we know for a circle that's x minus h squared plus y minus k squared equals r squared. From here, two things we must know. We must know the radius, and we must know the center. In this case, we were given the center directly. There's our value of h. There's our value of k. Let's go ahead and plug that in first. X minus h, that's x minus a -1, becomes x plus 1, plus y minus 2 squared equals r squared. From here, the only other information that we need is the radius. The only other information we're given is that the point 34 lies on the circle. Now in the book, you may see it written like this, where it says this point is on the circle. You may see where it says that this is a solution point, which is the same thing. A solution point is a point on the graph. So in this case, remember, anytime you are given an ordered pair that is on the graph, you are given an x value and a y value that is a solution to the equation. So in this case, I can plug 3 in for x, I can plug 4 in for y, and now the only unknown in my equation is r squared, which is the last thing we need to find. So let's go ahead and simplify this. 3 plus 1 is 4. 4 squared is 16. 4 minus 2 is 2. 2 squared is 4. R squared then is 20, which means the radius would be the square root of 20. We don't really need to know the radius, though, because we're using this standard form in which we need r squared. So our final equation becomes x plus 1 squared plus y minus 2 squared equals 20. Final one here, number 3. Triangle has vertices at -1, 2, 1, -4, and 2, 3. It's shifted 3 units to the left and 2 units up. What are the vertices of the new triangle? Well, let's quickly just sketch what we're given here. We have vertices at the order pair -1, 2, 1, -4, and 2, 3. So there's our triangle. We want to take this triangle now. We want to lift it off this coordinate plane, and we want to shift it 3 units to the left, 2 units up. So I want to take all of these points, shift them up 2 units, and take all of these points and move them to the left 3 units. Let's start with that movement to the left first. So I'm going to take each one of these 3 ordered pairs, and if I'm shifting something left or right, that is affecting the x-coordinate, because the x-coordinate tells us how far left or right to go. In this case, I want to take each one of these vertices, or each one of these ordered pairs, and take this x-coordinate and shift it 3 units to the left. Since we're going left, that means I need to subtract 3. So -1 minus 3 is -4. 1 minus 3 is -2. 2 minus 3 is -1. Next, we need to take each of those vertices and shift them up 2 units. If we are going up, that is now affecting the y coordinates. We're going up 2 units, so now we need to add 2 to each one of those y coordinates. 2 plus 2 is 4. Negative 4 plus 2 is negative 2. 3 plus 2 is 5. There now are the 3 vertices of our shifted triangle.